The following is my presentation on remote sensing of Arctic lakes and wetlands. To provide a greater understanding for the context behind the importance of our project, here is a recent event that happened within our target region. Aklavik, a community of 600 people, was flooded in May this year by the spring melt from the Mackenzie Delta that borders the community. When pieces of melting blocks of ice get stuck and crowded in the channel, it backs up the flow of melting water and puts communities such as this one at risk. A state of emergency was declared during the flooding as many people were displaced from their homes and lacked supplies needed to get back on their feet. In understanding the seasonal patterns of flooding and remotely monitoring areas of high risk, better management of these communities as well as the wildlife impacted by fluctuating water levels can be achieved. Additionally, this is just another prime example of the seriousness of climate change and a reminder of just how sensitive the Arctic environment is to rises in temperature. The IPCC 2021 report was recently released and once again stated the severity of rapid rise in global temperature by 1.3 to 2.6 degrees per year. Along with a high degree of uncertainty towards how climate change is going to impact all environments, Arctic ecosystems are an even greater mystery due to the minimal understanding of their typical seasonal changes. Therefore, predicting the effects that will be caused by climate change and how the altered Arctic environments will feed back into climate change is still a large question that is waiting to be understood. The aim of this project was to gain greater understanding of the seasonality of hydrological patterns across the water bodies in the Arctic environment and how these patterns are being affected by climate change as well as natural resource extraction using remotely sensed data. Due to the remote location of Arctic bodies of water, it is harder to access the vast amounts of lakes for in-person field surveys and data collection. As well, the harsh conditions of below freezing temperatures and ice formations starting in September and continuing until mid-May creates a short window of time where useful information can be gathered. We compiled data from our target regions of Inuvik, Aklavik, Trail Valley Creek, and Tatiatuk in the Northwest Territories from different open source and commercial remote sensing platforms. This data was required specifically from a commercial remote sensing company known as Planet. They provide satellite data across long temporal ranges that cover the visible, near-infrared, and radar portions of the electromagnetic spectrum. My portion of our project focused on obtaining and working with data from the commercial remote sensing company Planet. This company has launched multiple fleets of small satellites that possess 4 electromagnetic sensors that are referred to as doves. Since 2017, these compact satellites have been used to form constellations that rotate the Earth in various formations, capturing imaging of its surface at 3-meter resolution. As of 2021, they have launched and are operating more than 200 individual satellites that combine to form these constellations. As well, due to the high density of imaging platforms, Planet provides accessibility to same-day satellite imagery and 24 to 72-hour repeat imaging over the same geographical area. Using a series of images across a date range from late May to the end of August, multiple different processing techniques were utilized to detect the changes in the bodies of water and map the differences. False color composites and normalized difference water indexes use the high reflectance characteristics of vegetation in the near-infrared region to produce imaging that distinguishes between water, which will be dark, and vegetation that will be bright. Water fraction mapping combines these NDWI images with calculations that focus on using the numerical index thresholds of land and water to convey very clearly the extent of that of water versus that of the surrounding. The following are a few examples that show interesting areas of change that were detected over a relatively short period of time. On the right, you can see in the beginning of June, the vegetation is not very apparent as it is dark and covered in water, but as you extend through the growing season and into August, the vegetation becomes bright pink and you can see that it changes the extent of the overall body of water. Same occurs on the left in these other 2 examples, and you can see evidence of sedimentation changes throughout the season. This connects to the overall concept of the project because it will be used as a validation dataset for the Sentinel-1 radar data models that have been programmed and trained to identify open bodies of water through specific parameters associated with radar imaging. Overall, this project will continue to develop to help gain greater understanding of the base patterns of seasonal changes that are occurring in the bodies of water in the Arctic.